Today in this video, I'm going to be discussing MPLS or multi-protocol label switching and give you a quick overview on how it works. Now, with MPLS, there are some terms that you need to know and what the service provider uses. And one term is called a provider edge router. And normally what that is the edge of their provider network. So in this topology that I have right here, router 5, that is going to be a PE router, and router 1 is also going to be a PE router. Now, in an actual LAN, like a customer edge LAN, the device hooking up to that PE is going to be called the CE device, which is the customer edge. But in my network here, I just have two computers hooked up, so technically these computers, they'd be called CE routers. So I'll label that. And then every router that is running MPLS in a service provider network, they are going to be called LSRs. So they are label switch routers. And routers 1, 2, 3, 4, and 5, they're all running MPLS, so they're going to be called label switch routers. Now, as packets move throughout this MPLS network, the path that it takes is going to be called the LSP, the label switch path. So if I send a packet from router or R6, computer 6, all the way to computer R7, the path that it takes, that's going to be called the label switch path. Now, what makes MPLS so great is that it is a layer 2.5. And what that means is you will never get to see, or the routers that are running MPLS, they will never see the layer 3 header. Okay. Now what does that mean? Well, I could run on my customer edge LANs, I could run IP version 4, which we all know. I could run IP version 6, and the service provider network doesn't care, because all I care about is this label that MPLS puts on, they called forward equivalency class, or FEX. But in this video, FEX are going to be IP networks, and I'll show you what that is. So every route that, let's say, router 1 knows about, let's say router 1 knows about 4 routes. Okay, 4 routes. And I'm running MPLS, so that means I should have 4 labels. And these are just locally significant. So router 1's labels are going to look different from router 2's. They don't matter. Same thing with router 3 and router 4. They're going to have their own labels, and they don't need to match. So as packets are being routed from, let's say, the path, the label switch path is going to go from R1 to 3 to 4 to 5 this way. R1 has his labels, R3 has his labels, 4 and 5, right? Now, when R1 is going to send this packet to router 3, router 3 is actually sending his labels for certain routes to router 1. So router 1 is going to address this packet with router 3's label for that specific route. And then router 3 gets in and was like, oh, I got a label for this packet, and let's say it's part of the 10 network. I'll just say that. It's like, okay, well, to get to that destination, I need to send it to router 4. So what is router 4's label? Well, during this whole label distribution process or protocol, router 4 also sent his labels to router 3. So router 3 rips off his label and then puts on router 4's label. So router 4's label for this 10 network could be anything. I mean, I think it could be a number, it's a 20-byte number, 20-bit number for labels, but normally it's going to start off like from 10. So if there's only 4 labels on router 4, it's probably going to be something like 12 or something like that. So anyways, so router 3 is going to put on router 4's 12 label and then ships that off to router 4. Router 4 is going to do It's going to receive that route, and it's going to look at, okay, to get to the 10 network, I need to send it to router 5. Now, router 5 is the PE router, the provider edge, and that's where MPLS stops. MPLS does not go into the customer's LAN. So, what router 5 does, since that is the end of this label switch path, router 5 actually doesn't have a label for the 10 network. And I'll show you in the output that at the end of the path there's going to be no label. Okay, and he actually tells router 4, I have no label for that. So then router 4, when he actually sends it to router 5, he's gonna do this penultimate hop popping, meaning I'm gonna pop that label off. I'm gonna take it off, and router 5 is gonna receive this packet with no labels, and then it should be able to route from there. So let me get into the CLI, and let's see this label switch path. So I'm gonna go into, or these labels I should say. Let's go to router 1, and I'm running OSPF in this service provider network, so let me do show IP route OSPF. Let me see my OSPF routes. And I have, how many routes do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7 OSPF routes. I'm gonna guess I have somewhere around 7 MPLS labels. And to view those labels, you go into show MPLS forwarding table. And then here we go. Let's see how many labels I have. 1, 2, 3, 4, 5, 6, 7, 8. This 8th label is actually my point-to-point layer 2 VPN connection that I have set up here, but don't worry about that. Other than that, we have 7 labels, just like we have 7 OSPF routes. And if you notice, on the outgoing label, you'll see pop label. It's because this pop label, my neighbor doesn't have a label for it. That's that whole penultimate hop popping type thing. So yeah, and here are the local labels that this router has set. And then this is the outgoing label that my neighbor router has set, and they told me about it. And you can see that this is the prefix that I have put for this label. And it's all about swapping labels until it gets to the very end. Then we do the whole pop label type thing. And let's see here. So the destination for this layer 2 VPN that I have is from router 1 all the way to router 5. Router 1 to router 5. And it's the loopbacks. So let's go to router 5 real quick and look at his label for 5.5.5.5, which shouldn't be anything because it's directly connected. He doesn't even have it. If I do show IP route connected, yeah. So I don't even have a label. That's why you also don't see it in here. So I'm telling router 4, hey, I don't have a label for that 5.5.5 loopback address. And let me go to router 4 and let's view that. Show MPLS forwarding. Yep, there you go, pop tag. Now, that is the basics of MPLS. I assign a route, a label, and then I share it with my neighbors. And then this label is, again, layer 2.5, so layer 3 never, the layer 3 header is never seen. Now, let me prove that to you. So, let me go into router 6. I disguise it as a computer, but I just used another router. It's only just for ping purposes. And if I do show IP interface brief, notice here I have a 192.168.0.1 address. And if I go to router 2 real quick, which is inside of the service provider network, and if I do a show IP route, I do not have a route for a 192 network. So I shouldn't be able to route traffic, right? But I created this layer 2 VPN, and all I'm doing is looking for labels. And this layer 2 VPN, I created a tunnel between R1 and R5, and I'm using MPLS as the transport. So let's go to router 6, and let me ping router 7, which is 192.168.0.2, and it worked. And if we go to router 7, just to verify his address, show IP interface brief. Yep, so I pinged him. Now, that was one layer 3 protocol, IP version 4. What about IP version 6? Does router 2 even know anything about IPv6? Where is router 2? Show IPv6 route? Nothing. I don't know anything about IPv6. But my two computers do, and I'm going to ping it across. Nope, that's router 2. Let me go to router 7. Alright, so what is my IPv6 address? If I do show IPv6 interface brief, and I have an IP address of 2001::2, and the other side is 2001::1. So let me ping it. 2001::1. Bam. Look at that. I lost one ping, but did it again, got all 5 pings. So this is proving that the service provider network, the MPLS network, my MPLS WAN connection, they don't care what layer 3 protocol I'm running. Because again, MPLS, layer 2.5. So I hope this gave you a better understanding of how MPLS works. This is a service provider technology, but becoming a route switch engineer, you still need to know how this works, and it's still relevant, and this is definitely part of CCNA, it's definitely part of CCIE, and as they revamp CCNP route switch, you're definitely going to have to know more about MPLS. So I hope this was informative for you, and I'd like to thank you for viewing.